Malaysia is the largest producer and exporter of palm oil. Palm oil mill effluent is a wastewater generated from palm oil milling activities that consists of various suspended components. Since palm oil mill effluent is produced in a large amount at a time, it is very difficult to handle and the treatment is very costly. So, the cheapest and the simplest way is by discharging the untreated wastewater of Pome into river and stream. Nowadays, various treatments are taken to ensure that the wastewater is properly treated so that when the wastewater is discharged, it will not cause pollution to the community and environment, especially streams and rivers. In addition, the palm oil mill effluent treatment must be carefully handled so that it will not lead to the human health and environmental pollutions. Examples of method or technology that can be used to treat palm oil mill effluent is electrocoagulation, which called EC, and membrane bioreactor technology, which called MBR. There is two types of journal that have been observed in my study, which is the first journal is treatment of palm oil mill effluent by using electrocoagulation as an alternative method, and the second one is treatment of palm oil mill effluent by using membrane bioreactor technology as the second journal. The parameters analyzed in the both journal, which are chemical oxygen demand (COD), total suspended solid (TSS), and pH. Based on the first treatment using electrocoagulation method, the determination of analytical method, which is COD, TSS, and pH, were calculated using this equation, where C0 and Ci are the concentration of COD before and after electrocoagulation with unit milligram per liter. The same equation will apply to calculate the determination of TSS. For this treatment, the determination of optimum electrocoagulation will use a variety of voltage, which is 0 volt, 25 volt, 50 volt, 75 volt, and 100 volt for 25 minutes. The voltage applied in this treatment will have significance for COD removal. It is expected that when the voltage increase, the COD removal will increase too. So, for this study, I will focus on 100 volt to determine COD, TSS, and pH. It is because when using 100 volts for 25 minutes, the result shows very highest and very efficient than the other voltage. So, here is the graph of COD and TSS removal efficiencies and pH. As we can see, when using 100 volt, we can get the most efficient results than the other voltage. The second way treatment is using membrane bioreactor. The treatment will carry out by using a ratio 70% of wastewater and 30% of active sludge with stirrer and aerator in a large scale. Next, the figure shows configuration of membrane bioreactor technology system, which called MBR. The left side is submerged MBR and the right side is side stream MBR. So, here is the results for the both treatment. Based on the table, we can get the COD value and TSS value, which is measured in milligram per liter, and pH value. For the first journal, which is using electrocoagulation method, the table shows the final result by using a voltage of 100 volt for 25 minutes. The initial COD is 4,900 milligram per liter and was decreased to 210 milligram per liter. The COD amount of 210 milligram per liter is nearly match the DOE minimum requirement, which is 200 milligram per liter. The initial TSS concentration is 4,000 milligram per liter and was reduced to 30 milligram per liter at 100 volt and 25 minutes of electrocoagulation. As we can see, the final 30 milligram per liter concentration already meets DOE standard B requirement, which is 400 milligram per liter for TSS. The sample wastewater of Pome with pH 7.44 was used and the final pH was increased to 8.97 at 100 volt and 25 minutes when the electrocoagulation process finished. For the journal 2 that's using membrane bioreactor technology, the result for COD was 663 milligram per liter, do not correspond to the DOE standard, where the result for TSS was 353.3 milligram per liter and pH was 8.4, that is alkaline, which is acceptable to discharge. Okay, let's move to the advantageous part of electrocoagulation and membrane bioreactor. Electrocoagulation is a simple and effective technology. Besides, only low operating costs and power requirement needed to run this process. It is also have a low maintenance and /minimization. For the membrane bioreactor, the membrane bioreactor treatment is safe to use and very cost-effective. This treatment is very important to avoid pollution issues, especially when the wastewater is discharged into the rivers and streams. Besides, if the wastewater is untreated before discharge, it will affect the environment and society. For example, it can cause harm to the aquatic life, so that the aquatic life can die. Next, it can cause the water contain toxic and it will affect to the water supply, so that the plant, humans, animals cannot get the fresh water or clean water to drink. Other than that, destruction of the natural habitat and the wildlife that live in the habitats. So, for the conclusion, it is proof that the both treatment is safe and can be used in treating palm oil meal effluent. But for this study, it can be concluded that the electrocoagulation method is the best and effective way to treat palm oil meal effluent than the membrane bioreactor. The recommendation for electrocoagulation method is further analysis of electrocoagulation time, voltage applied, and other parameters is needed to achieve the best results of COD and TSS. In addition, the experiment and analysis should be conducted within 24 hours after the samples was collected and should be kept in the dark place. That's all from me. Thank you.